All right, so this is just going to walk you through the answers to this first explore here. Hopefully the videos help clarify components. The kind of first part is around this idea of the dark sky, where we would, if we had an assumption that the universe was static and not changing, basically there's so many stars that are out there, we would expect that everywhere we look in the night sky, we would see a star. And so the night sky wouldn't be dark, it would be bright. So what this is telling us is that is light travels in straight lines. We'd have a star at every point, and we'd have a bright sky, which is obviously not what we have. So this is one piece of evidence towards our changing and growing universe. This one, again, is going to talk about this idea of motion from what we observe from our space on Earth, right? And so these were a lot of the problems with early ideas of the universe, of our observation from Earth. We feel like we're static, that we're not moving. So we see the sun and the moon move. And so it can be misleading, right? So the idea that the Earth is rotating, the sun isn't moving, but from our perspective, those things can be off. All right. Which could help explain why the night sky is actually dark. So the two that we would select is the universe is so massive and relatively young that a lot of that light has not reached Earth yet. Remember that we have billions of light years that this stuff is traveling. And that as the universe is expanding, we have these wavelengths of light that become stretched. All right, this next part talks about looking back in time. And since we have such massive distances in the galaxy, in the universe, the things that we're seeing now have taken thousands, millions, billions of years to reach us. And so just like looking back on an old photograph, what we're really seeing when we look at the stars is how they were, not how they are necessarily currently. Because, again, light has a finite speed, we show the past, and then those stars that are located in our galaxy that are close to us are much younger than the ones that we're seeing in the same image, because the light has different distances to travel. All right. The idea that if we weren't changing, if things weren't moving, then our images from the past would be current to the present, but we know that that's not the case. This then goes through the timeline. The videos really talk much more about the timeline of this. The idea of that we have this massive expansion. So on our y-axis, it's the radius. So you can see this exponential growth right here, and then this flattening out, and then this expansion kind of curve again. So, and then on the bottom, we have our x-axis is going to be the age in this kind of truncated. We can't have a linear scale. You can't go from a hundredth of a second to 3 minutes to billions. It would just wouldn't look correctly. So we have this adapted scale down here so that we can actually see everything on one graph. All right, and that's just basically what this shows. So we have the y scale, which is our size. We have that it expanding very quickly. You see that large jump at the start of the curve. And then the color shows the cooling of matter as it expanded. So again, a massive amount of heat when everything was so dense, and then slowly cooling, and that cooling allowed for the materials and structures that we know today to actually form. And I think that's it. So again, a very short section. We're going to go into our next section to try to take care of Explore 2 here as well.